When naming organic compounds, we reference the number of carbon atoms in the carbon chain. Okay, so if we have only one carbon atom, it's just going to be, if it's an alkane, it'll just have C and then H4 using that 2n plus 2, 2n being the number of carbon atoms. So 2 times 1 plus 2 would give us 4. 2 times 2 plus 2 would give us 6 for 2 carbon atoms. And the name for these alkanes, if they're in a straight chain, is methane, ethane, propane, butane. All right, those four don't have any real rhyme or reason to the names for the first four numbers of carbon atoms there. But then after that, with 5 and more, you recognize the prefixes, the Greek prefixes, penta, hexa, hepta. So this is pentane, hexane, heptane, octane, nonane, decane. There are more, but these are the ones that will be relevant to this class. So it's just the first four carbon atoms that you need to remember this particular sequence, and then it's just based on the Greek prefixes. Okay. Now, when we're talking about alkenes, remember these are the ones that have a double bond. The name is essentially the same thing. We can't have a double bond when there's only one carbon, but when there's 2 or more carbon, you can have a double or a triple bond for the alkynes. And the name, we just change that A to an E to make it an alkene, or to a Y to make it an alkyne. So ethene or ethyne, propene, propyne, butene, butyne, and then we have the Greek sequences again: pentene, pentyne, hexene, hexyne, heptene, heptyne, octene, octyne, nonene, nonine, decene, and decyne. Okay, so we use these names as the main part of the name for an organic compound. We will be branching off from these base names, but this serves as the foundation. Okay. Now, oftentimes I have a molecule, I might have a molecule something like this, and it has a branch. Okay, so in a case like this, that branch we also have to name. Okay, so we have 4 carbons in our chain, but then we have a side chain of 1 carbon. Okay, so when we have a side chain, or if it's as a group, the group would be this side group or chain of carbon atoms. When it's a group, instead of the main chain, we name it with a YL at the end. So methyl would be this group. This attachment is a methyl attachment to that butane base chain. Okay, so as a group, we end it in YL: methyl, ethyl, propyl, butyl, and then the Greek prefixes again: pentyl, hexyl, heptyl, octyl, nonyl, and decyl. Okay, so if I had a 3-carbon chain on attached to the base chain, it would be a propyl group. Okay. Now, if you look at this, you might be asking yourself, well, how do I know that this isn't an ethyl side group? And that's a good question, because here I could say, well, maybe this is an ethyl propane instead of a methyl butane. Okay, so the way we distinguish that, we have a rule, and the first rule for naming organic compounds is to find the longest chain. Okay, so between my propyl and butyl, the butyl is the longest chain, and so that is going to be my base name. Okay, so the name for this is going to be my base name is going to be butane. It's an alkane, all single bonds, so it's a butane. But then I need to specify this methyl. Okay. Now I have a methyl group, but where is that methyl group attached? Okay, it's attached to the second carbon. Right, now, again, you might be thinking, well, why wouldn't you start from this side, the third carbon? Well, we number the carbons in our chain so that our group will have the smallest number. If I number from this side, I get 2. If I numbered from this side, I would get 1, 2, 3. Okay, so the name for this compound is 2-methyl butane, and actually this is all one word here. There's no space here. It's just methyl butane. 2 dash. Anytime we have numbers in our name, we put a dash to the other letters. All right. So 2-methyl butane, all one word, no space. All right, so our second rule is to number the chain so that the side groups will have the smallest number. Okay, the side groups being anything that is attached on the side of that molecule, essentially. All right, if there are more than one side group, okay, we look at the one with the that comes first. Okay, so that the first side group, I'll specify that the first side group has the smallest number. Okay, so what we end up with, let's look at another example here. Let's say I have something like this, all right, and I have well, let me change this a little bit. Okay, let's say I have a molecule like this. Okay, what is my what's the name of this? First, I find the longest chain. Okay, so 1, 2, 3, 4, 5, 6. That's going to be a hexane. Okay, so this one, my base name is a hexane. Again, it's an alkane, all single bonds, so it's a hexane. But now, how am I going to number this? Okay, well, if I numbered from this side, I'd have 1, 2, 3, and then this is what group? Well, I have 2 carbons that are attached, so that would be an ethyl group. So this would be 1, 2, 3 ethyl for 5-methyl. Okay, if I started from that direction. And so my first group would be 3. But if I start from this direction, 1, 2-methyl, 3, 4-ethyl. Okay, so I'm actually going to start from this side because my first number, all right, following the second rule, I numbered the chain so that the first side group coming this direction, my first side group has the lower number. If I come this direction, my first side group has a 3. This way, it's a 2. Okay, so that's how I will number that. And now I specify where each of these groups is in the molecule. I have an ethyl group on the 4th carbon, so this would be 4-ethyl, and then 2-methyl, right? Because that's 1 carbon there on the 2nd carbon of my chain. Okay, so I have another dash to separate the numbers, -2-methyl hexane. Again, all one word, no spaces between anything. Okay, we put hyphens separating the letters from numbers. So this is 4-ethyl 2-methyl hexane. Okay, so now we have another question that would arise in this. You might be thinking, well, what if I wrote 2-methyl 4-ethyl hexane? Wouldn't that represent the same thing? And so we have a few rules just to make sure that we don't have multiple names for the same compound. And our rule in this case, when we have multiple groups, we name them in alphabetical order. Ethyl comes before methyl, and so our third rule is to name the groups in alphabetical order. So as in this example, I name ethyl before methyl because E comes before M in the alphabet. Okay, so let's look at another example here, and let's see if we can't name this compound. Okay. All right, let's go ahead and put a double bond in there. All right. So first of all, what is our longest chain? We find the longest chain. Now, you might be tempted to look at this and say, okay, I have 1, 2, 3, 4, 5, 6, so that would be a hexane, right? Well, no, we're finding the longest chain, and it doesn't have to be all in a straight line. Okay, so we would have 6 carbons if we went that way, but 1, 2, 3, 4, 5, 6, 7 carbons if we took that, and that is actually the longest chain. So that is where we will be starting. Okay, and I'm just looking at this, and I'm going to simplify this just a little bit. I'm going to use this as my example. Okay, the same concept essentially. 1, 2, 3, 4, 5, 6, 7, 8 carbons now in this example. So this is going to be an and then, but I have a double bond, so this is an octene. Okay, the ENE representing that there is a double bond in there. All right, so but I need to specify where that double bond is. What carbon does it start at? All right, so here's my longest chain. Now how am I going to number that? All right, well, I number it so that the first side group has the smallest number. Okay, so and by side group it would not only include the actual side groups but also any functional group. Okay, this double bond serves as what we call a functional group, meaning that it has a special function in the molecule. Okay, and so we look at that as well as the ones that are physically attached on the side when we consider the numbering. So if we numbered from this side, we'd have 1, 2, 3, 4. That begins my double bond. Or 1, 2, 3. That's my first side group with the methyl. Okay, so this is going to be 3-methyl, 1, 2, 3, and then 4 starts my double bond. Okay, so it's my 4. I'll put that one here. It's a 4-octene, telling me I have 8 carbons in my longest chain, so that's octene, and the double bond, the ene, is on the 4th carbon, so it's a 4-octene. Okay, but I have this 3-methyl side group, so I attach that here. This is 3-methyl dash 4-octene. Okay, so just following our rules. Oh, and by the way, the base name, you know, I mentioned about the alphabetical order. That's only for the side groups, not the base name. You see in this example, although E comes before M, H also comes before M, but it's only the side groups that I alphabetize. The base name is always at the end. Okay, so regardless of what I might have out here, or what sequence it is, what attachments, the base name is always at the end. Okay, so let's look at a few more examples to get some additional practice with this. And let's do one like this. Okay. Well, let's go ahead and... Okay, how about this one? Let's make it a little more interesting as well. Okay, let's put a double bond there. Okay, so we want to name this beast. So we just follow our rules. Our first rule: find the longest chain. All right. So what's the longest chain? 1, 2, 3, 4, 5. I'd only get to 7 if I went that way. So 6, 7, 8. So again, this is an oct, and then it's a double bond there. So it's going to be an octene. All right. And then where do I start the numbering? Do I start from this side, 1, 2, 3, or do I start from this side, 1, 2? Right. I'm going to start here, 1, 2, because that gives me the lower number for my first side group or functional group. Okay. 3, 4, 5, 6, 7, 8. Okay. So I have a 2-octene. That's my base name. And then what side groups do I have? All right, well, here I have a methyl, and it's on the 6th carbon. So this would be a 6-methyl. And here I have a 2-carbon side chain that's attached on the 4th carbon. So this would be 4-ethyl. Okay, so it's good to, you know, kind of label all of our side groups or our functional groups. Okay, we've got our base name for the main chain there, and then we look at what is everything that is attached to it. Okay, and how do we name those side groups? Each side group has its own name, and so if we name those, then now that we have them named independently, we can go through and say, okay, how do I arrange those? Well, I'm going to name them in alphabetical order. So then I can look and say, okay, here I have an ethyl and a methyl, and so the E comes before the M, and this will be 4-ethyl-6-methyl. And I didn't quite leave myself enough room there, but 4-ethyl-6-methyl-2-octene. Okay, and again, all one string of characters. We put hyphens in between the letters and numbers, and there's no spaces in the names for these compounds. Okay. Now notice the numbers really isn't important, like what sequence they're in, whether I have 4 before 2 or 2 before 4. You know, the number isn't important. We number them according to, or we list them according to the alphabetical sequence, and then that number goes with the given group. Okay, so it doesn't matter where it's at in the molecule. It just matters the name of that group. That's what determines where we put that in the name. Okay. Now let's look at another example. Something like this. Okay. Oh, let's go ahead and make this something like that. All right. Yeah, we'll just leave it like this for now. What is the name of this compound? Okay, so we're going to find the longest chain. And what is the longest chain? Well, we have 1, 2, 3, 4, 5, and either way it's going to be a hexane. Okay, so our base name is hexane. And now, which side are we going to number it from? Well, clearly from this side, since that will give us the lower number to start with. Okay, and again, it wouldn't matter if I started here and called this 1, 2, because either way, I'm going to have a methyl group on the second carbon. If I started this as 1, 2, I'll still have a methyl group on that second carbon. So that symmetry there makes that where it doesn't matter. Okay, so this is a methyl group on the second carbon, so that's 2-methyl. Right? Now here I have 2 methyl groups. Okay, and they are on the third carbon. Right? So the way that I have a 3-methyl here, a 3-methyl there. Now when I put this in my name, since I have methyl, 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 I take a shortcut and I combine all 3 of those. So all the groups in the entire molecule that have this, they're the same type of group, they're all methyl groups in this case. I'm going to combine them all together, and the way I do that is I say this is 2, 3, 3 dash tri, because there's 3 of them, methyl. And then again, no space between the substituent names or the side group names and the base name. Okay, so when we have more than one of the same functional group attached, then we separate the numbers from each other with commas and just put them in numeric order. In this case, 2-methyl, 3-methyl, and we have 2 of them on that 3-methyl, so it's 2, 3, 3, and then trimethyl, indicating that we have 3-methyl groups on those carbons. Okay, so hyphens separate numbers from letters, commas separate numbers from numbers. Okay, so 2, 3, 3 hyphen trimethylhexane. All right. Now let's look at one more example here. Let's try something like this. We'll put in a few different groups here. I'm going to do it like this. Okay. Oh, let's just make it interesting for the fun of it, and say there's a triple bond there. Okay, so now let's name this long molecule. Okay, you know, sometimes you'll see a big scary molecule like this and you're like, oh my goodness, I have no idea what to do with that. But you know, do you just follow the procedure? You're gonna reference our rules, and you'll work your way through it. Okay, so we find the longest chain. Right? What is the longest chain? Well, I've drawn it all out, and that's going to be the longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons in my longest chain. And if I started down here, I still end up with 10 carbons either way. So this is going to be a dec, and then there's a triple bond, so that makes it a YNE, decyne. And what carbon does that triple bond start on? Well, I'm going to number this so that my numbers, I'll have the lowest number for my triple bond. Okay. Now in this example, 1, 2, 3, I'd have an ethyl group on my third carbon, or 1, 2, 3, I have a triple bond on my third carbon. So which way do I name it? Okay, number it rather. Now this actually gets into another rule that that is beyond the scope of our interests, really. But it turns out the triple bond has priority over the ethyl group. And so we name it, or we number it from this direction instead of coming that way. But that's not something that you really need to know. You won't see an example like this on a test or homework. Okay, so but that's just for the sequence. Once we have our sequence given to us, that's the important part. All right, so this is a 3-decyne. Now the rest of this, we're just following our rules again, and we have now our second rule. We've numbered the chain. Okay, and that one I had to qualify that a little bit, but now we name the groups in alphabetical order. All right, so first of all, let's name the groups. Well, here I have a 5-ethyl. Here I have, you know, I didn't do this molecule quite the way I wanted to. There, let's do this. Here I have another 5-ethyl. I wanted to illustrate another rule, and without this 2-methyl group, and that doesn't affect my longest chain either way, it'll be a 2-methyl. But I need that in order to illustrate my next rule. Right? Here I have a 7-ethyl and an 8-ethyl. Okay, so I have, remember, like I did last time, I'm going to group all the ones that have the same name. Here I have ethyl, 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 ethyl. So this is going to be a tetraethyl, and then I have 2-methyl. Okay. So the thing is, though, since these are all ethyls, I'm going to name the ethyl first and then the methyl. Okay. So what I have here, this is going to be 5, 5, 7, 8 tetraethyl. let's see if I can give myself enough room here. 5, 5, 7, 8 dash, to separate from numbers from letters, tetraethyl, and then I have a 2-methyl, so dash 2 dash methyl, and then I'll have my 3-decyne at the end. Okay, so what I wanted to point out here is that even though I have 4 of those, and so that makes it a tetraethyl, and T comes after M, but I don't look at the prefix when I'm determining the alphabetical order. I'm just looking at the name itself. Okay, so it's still the E that comes before M, not the T. Okay, so this is 5, 5, 7, 8 tetra for 4, tetraethyl, 2-methyl, 3-decyne. Right? So you can see even more complicated molecules, we just follow the same rules, but here I'll qualify this one. Prefixes don't count. The prefixes are not counted. Okay? So with just a few simple rules, many molecules can be named. All right? So we're going to stop there for now, and in the next segment we will talk about naming different types of groups. So far all we've looked at are alkanes or alkenes or alkynes. They're all hydrocarbons. But we want to also look at naming of a few different types of compounds that have more than just carbon and hydrogen in them, but they have different types of functional groups instead of just double bonds or triple bonds or side carbon chains. Okay, so we'll look at that in our next segment.